We're on lesson 4 of chapter 2, which looks at functions. So we're going to be finding different representations of functions and then identifying functions as well. First thing, this will help us identify them. A function always has one output for every input. An input is an independent variable, something you change, and then output is what changes because of that. So you can have only one output for every input. So here, this would not be a function because we have an input of 0, and we see that goes to 2 and 3. That would make it not a function, unlike this one where each input has only one output. They all have a partner. So you see how this one breaks that rule and makes it not a function. So when we do functions with x and y, x is that input, y is the output. X is the independent variable that we change, y is a dependent variable that changes because we changed the x. So for this example, it tells us to make a table and graph y equals 2x plus 1. So we're going to change the input here. We're going to have the input be 0, then 1, then 2, then 3, then 4. And see what happens here. So whenever we change the input, we do the function here. Y equals 2 times x plus 1. So here's that, right? 2 times x plus 1. So it would be 2 times 0, which is our input, plus 1. So what's our output? 2 times 0 is 0, plus 1 is 1. Now our input is 1, so we plug that into our function here. 2 times 1 plus 1. So 2 times 1 is 2, plus 1 is 3. Now we have an input of 2, so 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. We have 2 times 3 now. We have input of 3 plus 1. 2 times 3 is 6, plus 1 is 7. And then last one, 2 times 4 now for x. And that gives us 8 plus 1 is 9. So we see that there's a relationship here. See if it goes up by 2? That's because we are multiplying 2 times the input. So it's always going to be going up by 2. And then it starts at 1, so it's always going to be an odd number. But now we need to graph it. So we have an x of 0, a y of 1. So let's do that. 0 for x, 1 for y. We'll circle that in. Now we have a 1 for x, and then we have a 3 for y. So 1 for x, 3 for y. We have 2 for x, 5 for y. And look at that, we're going to be off the chart, but that's okay. We'll kind of make a guess. So when x is 3, our output is 7. So 3 for x, output of a guess. I'm going to guess it's going to be over here on 7. And then we have an input of 4 and output of 9. Input of 4 creates an output of 9. We're going to, it kind of made me easy because we're following a straight line here. See that? So that's what made that a lot easier for me. Here we need to determine if each relation represents a function. So we're going to do this, a table, then we'll do these two graphs and say whether these are functions or not. Alright, so we make sure every input can only have one output. Here's our input x, so our input of x gives you 5. Input of 1 gives you 4. Input of 2 gives us 3. Input of 3 gives us 2. So each one has only one output. So this would be okay. This would be a function that follows the rule. Let's check this one then. Alright, so remember the inputs are x, the outputs are y. So negative 3 doesn't have an output. That's probably not a good sign. But let's look at positive 1 over here. Okay, so when x is positive 1, I see two different outputs. I see something around a negative 2 right here. And I see an output of about 4.5 over here. That's not allowed, right? So the input of x had a 2, negative 2, and positive 4.5. And you see that happening a lot of places. Positive 3 has negative 2 and about 4.5 as well. So this would definitely not be a function because it breaks that rule. Every input can only have one output. This one looks really weird, but let's give it a chance, shall we? Alright, so we see, let's try a couple different ones and see if there's any multiple outputs. Here's an input of 1 for x. The output's at about 1/2. 2, only one output. 3, only one output. 4, only one output. 5, maybe there's an output eventually, but that's okay. And then negative 1, all these only have one output. So this looks like it's going to be a function then.